combinations, of course. So combination, just the order doesn't matter. So, just like if you have, this isn't on your notes, but just take a look at it. How many different bouquets could you make about those 3 from the 4 flowers below? I mean, the order how you put the flowers in the arrangement doesn't matter. You're just trying to arrange the items. So when we talked about permutation on Friday, we said, of course, the order did matter. If you had ABC, you needed CAB, BCA, all the different arrangements of it. But for a combination, we don't. ABC, those are the same letters as CAB, BCA, so on and so forth. You would not be counting those again. We're only looking at just the 3 letters. I don't care what order you put them in, it doesn't matter today. So we're using a combination. This is technically the formula, okay? But we're using our calculators, it's in that math menu. Now, the subscripts work the same as they do on Friday. N is the total amount of items you're selecting from. The second one, R, is the number of items you're actually arranging. So the subscripts work the same. Okay, here we go. Let's practice our calculator skills. So again, first I'm going to get into my math menu. I'm going to go over to probability, number 3, and then you just type in your subscript. So our first ones, we have 5, right arrow, that will take you to the second one. Punch it in, 10. Okay, I'm going to have you guys punch in the rest. Let's see what you get. Test the calculator skills first. Just have a test on this, right? 210, I like it. Let's punch in the third one. Kind of a big number. I need a bigger blank. And our third, or our final answer, our fourth one, 1. Got it. So again, just making sure we can punch those in our calculator, no big deal. All right, as always, little wordy, but the math is easy. So an exam consists of 6 questions. Any 4 may be selected for answering. I mean, really, you should answer them all, but okay, whatever. And how many ways can this selection be made? Does it matter the order that you answer the questions on the test? No. And the reason I talk about this, eventually, at the back, you're going to have to decide if it's a combination or a permutation. Order doesn't matter how we answer the question. So combination, there's 6 total questions, and you are answering how many? 4. Punch it in. That's our answer. 15, done and done. Got it. Okay. Jan Funkhauser has 10 different cut flowers. She's going to choose 6 to put in her floral arrangement. How many ways can she do it? Again, order doesn't matter how you arrange the flowers, so a combination. There's 10 to choose from. She's arranging 6. Punch it in. 210. Too easy. I love it. Nice, easy Monday lesson. Questions on that? Okay. This one's still easy, but wordy. We got to read close here. At the Royal Dynasty Chinese restaurant, dinner for 8 people consists of 3 items from column A, 4 items from B, 3 items from C. If columns A, B, and C have 5, 7, and 6 items respectively, how many different combinations are possible? Well, pretty obvious this would be a combination versus a permutation if we have to decide at some point. Now, this is just a little obnoxious because we're going to do a combination for column A items, 1 for the B, and I'm going to do 1 for the C. And we're just going to use our fundamental counting principle, good vocab there, and multiply all of these together. So I'm going to reread closely. How many total items are there to select from in column A? How many? 5. And you are picking how many? 3. Okay, read close. B. How many total items are there to select from for B? 7. And how many do you actually get to choose? 4. All right, C. How many total items are there to pick from C? 6. And we are actually getting to pick how many? 3. Okay, this is just a little obnoxious because we have to multiply all of those together using our fundamental counting principle. So let me give you a minute to type all of those in. And you can type them all in one line together. $7,000 for the width. That's a lot of different arrangements of items for dinner. Okay. Any questions on that one? That's the trickiest one of the day, I think. Okay, next one, similar, not quite as bad. Flip it over. Sue Les is having a dinner party. She has 10 different bottles of red wine, 8 different bottles of white wine on her wine rack. She has to select 4 bottles of red and 2 bottles of white to serve at the party. How many ways can she do it? So same thing, I'm gonna do a combination, well, let's do red first, I guess. We'll do the red first, and then we'll do the white, and then we're gonna multiply together. Okay, so let's just read closely. How many total bottles of red wine does she have to select from? 10. And she wants to serve how many here at the party? 4. Got it. Okay, read closely. How many total bottles of white does she have to select from? 8. And she wants to serve how many? 2. All right, and we're just going to multiply those together. Got it. Any questions? Love it. Okay, flip it. All right, out of the 5 officers on the school board, 2 will be attending the meeting together. How many different ways can they do that? Okay. So of course there's 5 of them, 2 of them are going together. Easy peasy, order they go in doesn't matter. Punch it in. I can't believe we're almost done with the notes. Here we go. Okay, Schnapper gets to pick 8 of her favorite 100 senior math kids for a senior yearbook photo. How many groups are possible? Now the order doesn't matter that you arrange the kids. There's 100 and she's picking 8. This is going to give you a fun answer in your calculator. Oh. Punch that in. You have something with an E in it. What does the E mean on your calculator? Times 10. So we never, it's one of those unwritten algebra rules, we never write our answer with E. That's a calculator answer. We want to put it as times 10, so we're in scientific notation. So I've just rounded the front half. I put like 1.861. We don't have to get crazy and write all the decimal places. A bunch of numbers, then it says E. What does it say after the E? 11. So you want to give that as a scientific notation answer, not with the E in it. All right, last one, and then we're just going to read and decide if we think the order matters or doesn't. Okay, Reynolds has 8 posters she wants to hang in her classroom, but she only has room for 4. How many ways can she choose the 4 posters she's going to put on her wall? Again, the order doesn't matter. We're just throwing the posters up there. There's 8 total of them, and she only has room for 4. Punch it in. 7. Love it. Okay. Final 3. It's our reading skills. So the last 3, we just have to say, would this be a permutation or a combination? So when you read it, you're asking yourself, does the order really matter on how I arrange the items, or can it just be completely randomized and it doesn't make a difference? 6 students are running for student government president, vice president, treasurer. How many outcomes are possible if these 3 positions to get selected? So permutation, the order does matter. Obviously your vice president, your president, it does make a difference. It's not just random. So this is a permutation. Let's read B. 6 people are on the board of supervisors for your neighborhood park. How many different 3-person committees could be formed from the 6 people? Combination. It doesn't say anything about the order of who's on what committee making any sort of a difference. All right, final one. And of course, we have to do something with ice cream, right? Baskin Robbins offers 31 different flavors of ice cream. If you can select 3 flavors for a bowl, how many 3-flavor bowls are possible? Does the order matter of the flavors you put your ice cream in your bowl? So permutation or combination? Combination. I'm going to sneak it in. Now I want ice cream. Got it. Any questions on those? That is it. We made it, guys. Our final notes.